Hello, this is Dr. Chin, and I'm going to do a short video tutorial on how to compute Cronbach's alpha with Excel. And so on the left of the screen, you have it's a 5-item scale, and we got 10 participants who filled out the items. And so the answers that they gave for items 1, 2, 3, 4, and 5 was for participant number 1. It was a 3, 5, 1, 4, and 1. And this is actually taken straight from your textbook, the tests and measurement for people who think they hate tests and measurement. This table is taken from page 54 from chapter 3. So I'm just going to walk you through really quick on how to calculate Cronbach's alpha. It really is pretty easy once you know some pretty easy shortcuts that you can do in Excel. So on the right part of the screen is the formula to compute Cronbach's alpha, and that's taken from page 53. And you can see the formula right there. It's basically K, which is the number of items, divided by K minus 1, and that ratio is going to be multiplied by the variance associated with the observed score minus the sum of all the variances for each item, and that difference is going to be divided by the variance associated with the observed score. So you kind of get another ratio with that too, and that's going to be multiplied with the ratio of K divided by K minus 1. So first thing that you want to do is you want to calculate the total score, which presumably that's how you score this instrument. Different instruments may have different rules as to how you should score them, but typically for most basic self-report scales, you typically sum up the items or get an average of the items. So total score equals to, and you can use the sum function in Excel. And you want to sum up the scores for participant number 1, items 1 through 5. Sorry, I had just had someone come into the room. Items 1 through 5, and you'll just sum them up just like that. See if I type in the same formula, items 1 through 5 again. That's how it works. And let me show you a quick shortcut over here. See the bottom right hand corner of the cell? If you move your cursor to the bottom right hand corner, it should change from this white cross into a black cross. And if you click on that and hold it down and then drag it down all the way down to the table, basically what it does is basically it copies that same formula and applies it to all of the corresponding columns for that particular row. So for this one, you could see a sum of items 1 through 5, and it's the same thing for this one. So if you're too lazy to type equals to sum 1 through 5 multiple times, just use that handy dandy trick. All right, so we got the total score over here. Let's look at the formula right here. So we need K, we need the variance associated with the observed score, and we need the sum of all the variances for each item. K is pretty easy. K is the number of items. So K equals to how many items that we got here? 1, 2, 3, 4, 5. So we got 5 items. We need the variance associated with the observed score. So the variance is basically a without going into too much details in the formula, it gives you a sense of how much the specific total scores deviate from the average of the total score. So it gives you a sense of how much the scores are distributed around the mean. If you were to do a quick Google search about this specific formula, the variance formula should be, there you go. Oh, no, not Excel. I'll show you that in just a little bit. So as you can see over here, you take each score and you would minus that from the average score of that distribution, and you would square it. So in sometimes people call this the sum of the square difference between each score from the mean, and you divide that by n minus 1 because this is not coming from your population, it's coming from your sample, and so we need to correct this value over here by n, which is the total number of people you have in your sample. Now, to calculate variance in Excel, you don't need to actually do all this. You could if you wanted to, but let me show you a shortcut. Shortcut is to just click equals and VR. VR stands for variance. And all you gotta do is just highlight, just click and drag your relevant individual data, close parentheses, and that is basically your variance associated with the observed score. So 6.4 is the variance associated with the observed score. So S squared, I wonder if we could do that. There you go. That is going to equals whatever this value is. Next is the sum of all the variances for each item. So what we need to do for this is we need to calculate the variance for each item across each participant, and then we need to sum them. Actually, just to, yeah, we could do that. All right, so equals variance, open parentheses, 1 through 10, close parentheses, and this is the variance for item number 1. And you can, again, type the same formula for item number 2 to get the variance for item number 2. You could also, just like what we did with this, click the bottom right hand corner of the cell and then drag it all the way here, and it's going to apply that same formula for each column. Alright, now we need to sum all of the variances for each item. So use the sum function, and you'll highlight the relevant cells, close parentheses. So this is going to be the sum of all the variances for each item. So sum s to the power of 2 item is this. Okay, so now we actually have all the parts to plug all this into the formula. So let's calculate Cronbach's alpha. Cronbach's alpha. So it is k minus 1, and I'm having 2 parentheses over here just so that I can organize my equation accordingly as to how I would want it to do, especially when it comes to subtraction over here, and partly also for the sake of me making sense of what's going on in this formula. So k minus 1, so k divided by, open parentheses, this minus 1, close parentheses. And the nice thing about Excel is that it actually color codes the parentheses, so you can kind of see which parentheses go with which one. So these parentheses go together. We definitely need to find some way to close this red parentheses and these black parentheses. Alright, so we know this ratio of k minus k divided by k minus 1 should be multiplied. So that's an asterisk right there. And you're going to have another close parentheses right here. And open parentheses. Variance associated with the observed score. So it's going to be this one minus the sum of all the variances for each item. Okay, and that needs to be divided by the variance associated with the observed score, which is this one. And so let me just clean this up a little bit, and I want this entire term. There you go. That should be just about right. So we've got a black parentheses right here and a black parentheses right there. The red ones go with the red ones and the purple ones go with the purple ones. Alright, click enter. Let's see. All right, something strange is going on here. 14, 19, 19, I probably screwed up somewhere. 14, 19, 19, 19, 17, 19, 13. That is the variance. That is correct. F15. Oh. Oh, sorry about that. This is where I went wrong. There you go. This looks better. So if we actually compare the values, and maybe it's a good thing that I made that mistake, and then that way you wouldn't feel too bad if you made a mistake as well in your calculations. It'll just take a little tinkering around to make sure you got the numbers right and to double check your work. So for this example, you can double check the values that we got over here with the values that are on page 54 of your textbook. So according to your textbook, the variance associated with the observed score, which is this one, it is 6.40. It's exactly what we got. And the sum of all the variances for each item equals to 5.18. We got 5.17 if you 7 basically, and if you were to round this to 2 decimal points, it's going to be 5.18. Your textbook says that the coefficient alpha is 0.24. We got 0.238, so that's pretty close enough. And so what I want you to do is basically replicate this same calculation for a different data set. And that data set is going to be, I think the title is, I uploaded this in Moodle, just said the title is going to be Reliability Dataset PY531 assignment. And this is going to be found on your Moodle page as well. So there you have it. This is how you would calculate Cronbach's alpha. Have fun with this. Let me know if you have questions. If this is the first time you're dealing with equations and sums and all that in Excel, hopefully this would be a fun experience for you. That's all, and let me know if you have questions.